rid of this. Alright, well, welcome nobody currently. I guess I'll say hi to people once they actually start coming in. But just for people who watch this later, actually, let me get the recording started too. Okay, so for people who watch this later, hi and welcome. So today I decided that I wanted to work on writing an interpreter because if you haven't seen any of the stuff I've done on YouTube, I've been creating a series called Editor from the Ground Up, and in that series I write in text editor without starting with an editor. So I started just using Bash, and that kind of failed because I don't know how to program in Bash very well, and so I switched over to Lua because I'm more familiar with it, and that went very well, and I managed to put together a pretty workable editor. And I took that and I used that to create a terminal editor written in C++, and that also turned out very well, and that is actually the editor that I'm currently using for most of my stuff. And real quick aside, if there's a problem with the audio level or something like that, just let me know. Okay. But yeah, just let me know if that is... okay, more about that later. Sorry, getting distracted with stream stuff. Okay, so yeah, so I was working on writing another text editor that was more advanced and used graphical, like OpenGL or Vulkan, probably OpenGL to start with, and like an actual graphical text editor. And I started working on that, and I kind of came to the conclusion that I wanted to actually make something that was more akin to how Emacs works, except for the fact that it doesn't use Emacs Lisp, because that's not my favorite language by far. And so I thought, okay, well, Emacs is basically just an interpreter with an editor built around it. And so I thought, okay, well, I guess I'll need to write an interpreter. And so I kind of, went to work on figuring out how to do that. And this was also coinciding with the fact that I, at the time, didn't understand how to make the text buffer that I wanted to use for it. So I thought, okay, I'll put that on the back burner. I'll work on other things. I released a video about creating a window using X11, and that kind of went by the wayside again. And so I figured, okay, I'll work on the interpreter, and we'll get that done. And so I kind of went to work on that, and I decided, some people have been saying I should do some sort of live coding, and that, kind of played around with that a bit and thought, okay, I'll try it. We'll see how that works. Because I've done live coding before, but personally I find the idea of watching somebody write code live about as interesting as watching paint dry. But apparently I'm not... that opinion is not a universal one. So anyway, all that said, all of that preamble done, let's just get started here. So first off, let's go ahead and open up the makefile here, because I did a little bit of work. I kind of did some stuff ahead of time. So I've got a fairly substantial makefile here. Got a bunch of stuff that will... let's see, is this... I think that's everything I need. I basically made it so that I can, just run it in debug mode, with the GDB debugger. I can also use the profiler and some other stuff, and there's also finally release mode here, which does some stuff. Unless somebody is particularly interested, I'm not going to explain all this. That's not really the point of this stream. And so we got main.c here, and actually I should probably go ahead and get started creating some extra files, because the editor that I made doesn't have the ability to make new files, so I have to actually make all that stuff from scratch outside using, in this case, touch or some other bash command. Okay. Actually, no, I'm not going to bother deleting that, but that's not the one I want to work on first. So the first thing that I need to work on is the lexer, because that's like the very first thing that an interpreter really needs. So the first thing that you need to do in order to get to make an interpreter is we need to take whatever the text is that we're taking in, whatever the programming code that we're taking in, needs to be broken up into workable tokens. So for example, let me actually go to a file that I kind of threw together that sort of goes through some of the syntax that I'm kind of thinking of using. So you take this code here and you break it up into individual tokens. Like for example, a comment is going to be its own thing. It's going to be mostly, for the most part, ignored, just because you don't really need to worry about tokens, or not tokens, comments. And yeah, there's really no particular reason to actually track them unless you're planning to take those and turn them into documentation or something, which is something far off in the future as far as I'm concerned. But for example, we would have this var token here. There'd be a token that is this identifier, which in this case is just x, but that's a token. And then this equal sign is a token, and the digit here, this 0, is also a token. So you break up the code here into different tokens, and then those tokens get processed by the parser. And so we'll go ahead and define a token structure. And this is going to have a token type. And then let me go ahead and include some headers real quick. Actually, I don't think I need this one. Yeah, I should probably store the row and column for now. So essentially what's going to happen is each token is going to have a type that's determined when it's lexed, when it's tokenized, and then this is going to be basically a way to reference the string that that token represents. So I'll have the file loaded in as a text buffer, and then the index and the length will reference the starting position and then how far that particular token actually is. And then row and column is more for the sake of when you're actually reading for errors. So if there's a problem, it's pretty common for the interpreter or compiler to say, hey, it's at line 33, and some of them will also include the column number, though that's not as useful as far as I'm concerned, but I just figured I would include it. I might not actually even make it a thing, but I'll just leave it there for now. Okay, let's go ahead and start listing out some more token types. So first off, keywords. Got some basic stuff like if and else. And I'm just going to go real quick and copy this so I don't have to keep typing it. Do match, which is basically just case by another name, or not case, switch by another name. And then guess loops. I want to include async and await, though they probably won't be implemented for quite a while. I really do enjoy being able to just kind of say, hey, I want this to run on some other thread without it being this whole ordeal, because like in C and in C++, getting stuff to run on another thread is a whole ordeal that you need to really like be very mindful of, whereas in other languages like JavaScript, for all the problems JavaScript has, this is one case where I think that they did something right, or at least more right than with C or C++. And I know why C and C++ did it, or at least I think I do, but yeah, it's just not my favorite feature. Okay. All right. What else? Let's see. And we'll list a bunch of types here. So in this case, start with integer types. And ideally, the user, like if in most circumstances, the user would not have to actually interact with types as like an explicit thing. For the most part, I would like it if I could make it so that the types are generally inferred, and if they can't be inferred, then it will sort of be handled like dynamic typing, unless you're doing something like if you're transpiling it into C, because that's something I wanted to be able to do. Obviously, you can't just infer types. You got to be, or hold on, strike that. You can infer types, but you can't deal with dynamic types very easily. So ideally, transpiling would require you to actually specify types a bit more explicitly, depending on if it's necessary. Like if it needs to know the type and it can't figure it out. All right. What else? What else is there to get? Oh, var and const. Definitely need those. What else? Function. Definitely need that. What else is there? I'm probably forgetting some keywords, but that's not a huge issue. I'll worry about that later. All right, move on to operators. That's a pretty big part of this too. Got all the basic ones. Some of the more usual ones like mod, which, what else? And or XOR kind of bouncing between whether or not I want to make and some of the more basic binary operators, or not binary operators, I guess Boolean operators, whether I want them to be keywords or use something more akin to C with the whole, something like this, and OR and XOR. I think I'll stick with those for now. And these will work not just on Booleans, but also on actual integers. Okay. Also need there we go. Okay, just go copy that real quick. Okay, so that covers, I think, all of the various operator equals. Also go ahead and add in just the assignment operator. What else? I guess we'll call it access. This would be the dot operator, so like, I don't know, string.length or something. That's the dot operator right there. And then we also need some more Boolean operators. So equals I'll just shorten these. It's a little easier. Greater than, and then greater than or equals. What else? Less than, and less than or equals. What's it called? The array operator, array access operator. It's the one that, hold up. Yeah, we'll do this. It's the one that looks like this. So, you have your array, and then you've got your index there, which, I don't know, I'm very tempted to make this language base 1 index, because the arguments for it are, I think, they're relatively strong, and the arguments against can actually, I think, be fixed with a bit of clever bit manipulation. I mean, other, like, even so, like, the amount of actual processing time it takes to add 1 or subtract 1 is so small that it's probably not a concern for the most part. But don't know, it's just something I was thinking about more. So we'll just leave that there. Okay, what else is there? What other operators? I can't think of any off the top of my head now, so I'll have to think about that for later. But need to do some delimiters, so things like open, paren, open brace, open bracket, that kind of thing. Because the brackets are also going to be used for array initialization. So you'd have something like this. And this would initialize an array of probably just like signed integers, maybe. I don't know. I don't know if I want to default to signed integers, but I think I will. So this would end up being an array, something like, let's see. I don't know, something like this, maybe. I'm not totally sure how I want to handle array kind of syntax. That's something I haven't really figured out yet. But it would be something like this. Or maybe this? I don't know. I haven't decided. I haven't figured out how I want to do that. Maybe we'll go with that. That's more recognizable to me. I'll stick with something like that for now. Anyway. Close bracket. Also need get rid of those. In this case, semicolons will be used if you want to combine statements into like a single line. So you could do something like, you know, something akin to that. But then if you want to break it up on multiple lines, you wouldn't necessarily need to use semicolons. Because I like the idea of being able to do a single line or combining multiple operations into a single line and have it still, the lexer still be able to recognize what's what. I guess that would be the parser. But anyway, point being, I want to be able to make it so that new lines aren't required for this language to function. Okay, what else? Oh, commas. I guess also colons. Those are going to be used for a couple of different things at least. The main one being for cases. So you've got a match, and then different cases require a semicolon. So you might have something like, you know, match, I don't know, C or X. And then something like that. So the colon would be used as a delimiter there. Okay, well, that's all I can think of for the moment, so I'll probably get back to that later, but for now we'll go to literals. don't think that I want to have like both string and character literals as separate things, because in C and a lot of C-like languages that's the case. But I think if you want to store a character just by itself, I think it makes more sense to just require that they specify the type. And otherwise, it would just be either something like a a U8 array, an unsigned character array, or an actual string as a type itself. Okay, what else? Include comment. All right, what else am I? I've already gotten all the Boolean literals done. That was like true and false and so on and so forth. I think the only one left is end of final. I think that's all of it. I think that's all the stuff that I really need there. Okay. Make a few functions. Need to I'll reverse the order there. Okay. I don't need to delete anything. Sometimes there would be cases where, because before, when I would do this, I would make a token value which was a union with a lot of different types, and one of them was a string type, like it was just a character pointer. And so you got to make sure that those are taken care of, deleted, but I decided not to do that this time and just use basically indexing the string that stores all of the file, all the code in the file. So that will make things a little easier. All right. Let's define a lexer. So this is going to need a pointer to the code. I also want to include a token. Call that current. Let's see, we should probably go ahead and include index and length. And these will be in reference to the whole code string there. Is there anything else I'm missing? I don't think I am. So go ahead and I'll also do create from, I guess, string, from text. Okay. I think that's good. And part of the reason I'm storing this here is so that I can Lex a token and then one sec here. All right. But anyway, like I was saying, I want to have access to the token that was just lexed, and this way I don't have to make like a function that peaks and then a function that consumes, and it just makes things a bit easier in my experience trying to do this. Okay. So, I'm just going to go copy all these. Get rid of that. Okay. I'll start with making this create from text function here. Deal with the from file later. All right, so then I guess we'll just go like that. Okay. And then just make sure that the index is 0. And everything else is dealt with in here, I guess. Okay. Yeah, we'll leave that as is. Hold on. Legit just forgot if the Lexer stores... Okay, it doesn't store row and column info. Okay, that's fine. That's only in here. Okay. Actually, we'll just set that to 0 because that you can just convert it directly, makes things easier. And then row is also 0. In fact, you know what? Save myself the trouble. I'll just go like this. I think that should work. And for anything let's see, do something like, actually, no, we'll do some actually valid code. We'll say var x equals 1 plus 3. So actually valid code, and then okay. Let's see if this stuff actually runs. Would that be a no? All right, that's current, not token. And code under click. Oh, okay. Fix that real quick. You know, token is so much more obvious. Oh. Change it to token. There we go. All right. Oh. Probably should read the entire error message instead of just the one bit. Cool. All right. Okay, so it ran. Okay. So let's actually start working on the Lexer. All right, where to start? All right. We'll do while, because I want to be able to control the index a lot more at a more granular level. start with the basics. Deal with some of the operators first. And each of these actually, I guess I'm gonna have to make individual ones for all of these. That's going to take a lot longer. Oh, that's no fun. Let's see, token length equals 1. Okay, I'll make a few of these and then I'll figure out the printing function. You know what? Right. Let's say that this is unknown and break. Actually, I can't break out of that. Let's have a return. Yeah. So this will return. All of these are going to return. At some point here in the near future, I'll set things up so that it'll detect all of the various assignment operators. But for the moment, we'll just do it like this. And while I'm here, okay. reach the end here, then that means that we are at the end of the file or string in question. Ugh, can't speak. So we'll go okay. It's got all those. Let's make this print things. Okay. I want to format this, say, token. Yeah, let's go with that. And then, yeah, fwrite, and this is going to be ooh, actually, I think I need to actually print the, or get the lexer for this. Because the tokens, like I mentioned before, do not have any kind of, they don't have a reference to the actual code string itself. They only have like integers pointing to it. Maybe I should though. I could just, I mean, it doesn't really change anything if I just give it the, hold on. I'm not speaking in complete intelligible sentences, but just a minute. Okay. So we'll do that, and then I guess I'll call it index. No, that doesn't make sense. We'll call it string. There. So now we'll throw in some pointer math just for funsies. Okay. So fwrite, not lexer, we want token, string, token length, and standard out. Okay. Don't think I'm missing anything there. Length gets modified, and the only problem is, hold on. Okay. I think that is all that I need there. Cool. Let's go to the main real quick and okay, cool. Now, for most of this stuff, it's not actually going to know what it is, if it even runs, so let's first see if it does. Okay. Return no value from a non-void. Okay. That can be fixed. Have all these return 0 since I mean, realistically, unknown should cause some kind of error, so we'll have it return 1. Oh, hello. Okay, so it's not advancing. We'll just advance the hang on, how do I do this? How do I want to do this? Let's do it like that. Perfect. Alright, that should run properly. Or not. Okay, what did I do wrong this time? Print. Well, at the very least, it printed out all the tokens. I should probably also make it so that it prints out the type. And need to deal with some of these. Just the end void function. In fwrite. Okay, well, let's see what the issue is. Is it printing all of the... Yeah, okay. Okay, so near the very end, it is freaking out. So why is that? Like I was saying, just about as entertaining as watching paint dry. At least for me. Okay. I think... Why is that doing that? Okay, well, I'm not a fan of this, but this is probably going to work, so I'll just do it like this. And then I think that will technically work. Okay, not quite. Okay, so just went all the way. Okay. Oh, wait, hold up. That's why. Huh? Okay, hang on. I know what's going on here. unless I'm mistaken, I think that means I don't need to worry about that extra space here. So I'm just going to remove that real quick. We'll see if that's correct. Yep, there we go. Awesome. Unused parameter file. Yep, okay, we'll deal with that stuff later. Let's go ahead and put something in here. Back to the Lexer and start filling this out with more stuff. And actually, I think I'll probably pause the stream or just end the stream. I think I want to just end the stream because this is a relatively decent place to stop. And yeah, I'll go with that. All right, well, thank you all very much for watching, and hope you guys found this interesting. And haven't totally decided what the streaming schedule is going to be. I'm going to have to hammer that out a bit, but I will probably stream tomorrow. We'll have to wait and see, but probably stream tomorrow and probably the same time. That seems to work well with my schedule. So anyway, thank you for watching.